All right, here we go. Trying to teach some of the lessons on convex and concave mirrors that come from Module 12 of Apologia Physics. Okay, so in a mirror, we talked about flat mirrors and they're going to reflect, you're going to see that image in the mirror. And how does that really work? Well, the light is reflecting off the surface of the mirror, but the brain is forming an image from where the light appears to have originated from. In a flat mirror, it appears to have originated from inside the mirror. So the image looks like it's behind the mirror, but we know that that has got to be fake because there's nothing behind the mirror. But that's because it's from extrapolated light beams. That's the light that we think we see coming from inside the mirror, and that makes it a virtual image. So on all of our ray tracing diagrams, if the light is extrapolated, it's not coming from the object, but it's like on the other side, then it's going to be a virtual image. If it's on the same side as the object, then it's not going to be extrapolated. It'll be from those reflected beams that are actually coming out of the mirror or reflected from the mirror, and so it'll be a real image. So that's some definition or explaining there that I think will help as we do these. So a concave mirror like this, if you look, all of our light beams are going to come into the mirror and they're going to reflect at an angle. And what is that angle that they're reflecting from? Well, if we think about this is really just a part of a circle. Of course, on my computer graphics, they're not quite circular looking, but they are in real life. So pretend with me that this is really a circle and not kind of a parabola curve. But if we were to draw the tangent line to the circle, I think the blue one's going to be a little bit easier. This tangent line right here, then the reflecting beam will come out perpendicular to the tangent line at that point. So we know that, of course, if it comes straight in, this will be perpendicular. So if it comes straight into that center point, it will be reflected straight back. Because if we remember our geometry, a tangent line is going to be exactly perpendicular to the radius. So imagine that this is kind of the part that we've taken, and then this tangent line is perpendicular to the line coming straight in. So that's that middle point. But these others are coming in at an angle. They're not coming from the center of the circle. They're maybe coming from over here. So they're going to be reflected back a little differently. But it will be perpendicular to tangent lines. So if we think about this as we do our ray tracing, I think it will make a lot more sense. All of these lines coming in horizontal are reflected back, and they all end up in the same point. And this point is the focal point. Okay. And then the radius of the circle is going to be twice that distance that the focal point is to the inside. So this will be our radius. Okay, so let's think about the steps of the ray tracing that we do for a concave mirror. All right, so here we have our arrow, we have our focal point, we have our radius. The radius is twice the focal point. We come in, okay, doing these on the computer, they're not going to be quite as straight as I would like them to be, but maybe I'll try with doing these. Okay, so if we go from the tip to the mirror, then based on what we looked at up here, it will reflect back through the focal point. So if we go horizontal, then it will reflect back through the focal point. So that's our first step. And then our second one would be to go in reverse. If it goes from the image through the focal point, I'm sorry, not from the image, from the object through the focal point, then at the mirror, it will reflect back horizontally because all we're doing is going in reverse. Oh boy, I hope this works out. And then the last one is just that we're going to go through the radius, And remember that if it goes through the radius to the mirror, it will be reflected back through the radius because a line from the radius to the outside of the circle will be exactly perpendicular to the tangent at that point. So if we go through the radius, then it will be reflected back exactly because that's already perpendicular to the tangent line. So from the tip through the radius, and we're pretty close. So it may help you if you do them in two colors. First the line, then its reflection. But if we look, this was our first one and it came down here. And then our second one went through the focal point and reflected back exactly horizontally, and then through the radius exactly. So these three meet up right here. So we have our answer in that our arrow is going, the tip of our arrow, because that's the point of the object that we were reflecting the lines from, or our tip of the arrow is going to be where these meet. So we can look at this. You might need to measure your object height, and then this one, it's slightly smaller and it's upside down. So those two are really easy to identify, right? It's reduced in size because it's slightly smaller. It's upside down, so it's inverted, or you can write it as upside down, however you need to. And then is it real or virtual? Well, we reflected all the light rays back, and we didn't have to extrapolate them or go behind the mirror with them. And so because the object and the image are on the same size, it's actually same side, it is a real image. All right, let's see if we can apply all of this to our convex mirrors and see if we can get kind of the same answers or the same steps in our head here. So it works very similar, except that the focal point and the radius are on the other side from where the object is, because to be a convex mirror, we have to be outside of the circle. So our object is outside of the circle, but our radius and our focal point are still inside of that big circle that our mirror is part of. So a ray that travels horizontally before it hits the mirror will reflect as if it came from the focal point. So we go horizontally to the mirror, and then it reflects as though it came from the focal point, but the focal point is now on the other side of the mirror. So we're just going to imagine that this came from the focal point, but we might want to make that dash because it's behind the mirror, but then that line has to continue to come up to be reflected back. So the reflected line I'm keeping solid, but the one that we extrapolated, it appeared to come from the focal point inside the mirror. So that's our first one. Then our second one is going to go, it's supposed to come from the focal point and be reflected horizontally, but we have to draw the ray as if it's headed to the focal point and then reflect it horizontally wherever it touches the mirror. So I'm going to draw the whole thing because I can't do halvesies on the computer. And then I'm going to erase this part. So it's as though it came from the focal point, but then when it hits the mirror there, I have to reflect it back horizontally. I'm going to draw them on the other side because we might need that. Never know. I'm going to dot it when it's on the other side because those are my extrapolated beams. Okay, and then the last one is supposed to come from R, the radius, and be reflected straight back. However, that's not possible, so we draw it as if it's headed to R and then reflected straight back. So pretty much we're drawing it as if it's going through our, oh, these are getting real different. Let's see if I can make this one a little different. Okay, just so I can see all the lines here. And then we have to dot it because this part is on the other side of the mirror, but it would reflect back here. So if we look on our lines that are on the same side as the object, they're all going out in different directions. Like rays from a sun, they're all diverging from each other. But if we extrapolate them, if we think about where they look like they're coming from inside the mirror, then they do intersect. So I drew them dotted because they're not really there, but that's where they look like they're coming from. And they do intersect all at this point. So here is our image. It's virtual because it came from inside of the mirror looking, because of the extrapolated beams, the beams that look like they're coming from inside the mirror, even though the light really doesn't go through the mirror. So it's a virtual image. It's upright, and it's smaller. It's reduced. Now, in our summary of convex mirrors, we found that actually all of our images will be virtual, upright, and reduced. In the concave mirror, you'll find that depending on where you put the object, inside of the F, between the F and the R, or outside of the R, is going to give you different image types. But if you remember that we're really working off of a circle, and if we go horizontally to that circle, we will reflect through the focal point, then that gives you those first two. We go horizontally, we reflect through the focal point, then we go through the focal point, but we reflect horizontally. So those first two steps are the same for both types of mirrors. We just have to think about the convex one where the focal point's on the other side of the mirror. And then, of course, if it goes through the radius, it's already perpendicular to the tangent line, so it comes back through the radius. In other words, when we're drawing this one, if we draw a line from the tip through the radius, it just reflects back to that spot. Okay, so hopefully that helps you in the mirrors department.